Hi everyone. So in this video, we're going to prove that the square root of 2 is irrational. And I think this is a really important exercise because it normally shows students a new way of thinking about mathematics, right? That we can prove things in different ways. We don't always have to do an affirmative proof. Instead, we can get more creative and use something like a proof by contradiction. And so the way we prove that the square root of 2 is irrational, and remember that an irrational number is just a number which cannot be written as a fraction of two integers, right? That's all it means. And so what we're going to do is assume that the square root of 2 can be written as a ratio of a over b. And this is going to be a and b are in the integers, and b is not equal to 0. But we're going to put one final condition on here, and that is that the greatest common divisor of a and b is equal to 1. Right? So all this means is that they don't share a common factor. Right? We want to divide through by everything we can. As an example, if I have 2 over 4, that's the same as 1/2, right? I can just divide out those common factors between 2 and 4. And so we're going to assume that a and b are in what's called reduced form. And now let's just show that we get a contradiction. Well, notice if I square both sides, I get 2 is equal to a squared over b squared in this case, right? Now I can move b squared over, and so I get twice b squared is equal to a squared. And notice that if a is an integer, right? If a squared is divisible by 2, then a has to be divisible by 2, right? And so this means that I can write a as equal to 2 times c, such that c is an integer, right? So I'm going to go ahead and do that. I'm going to say, all right, twice b squared is equal to twice c all squared, okay? In this case, I get 2b squared is equal to 4c squared. And now I do the same thing, right? I can divide 4 by 2, so I get b squared is equal to 2c squared. But notice what this means. If b squared is an integer and it's divisible by 2, then b must also be divisible by 2. And so that means I can write b as equal to some twice d, such that d is an integer, right? But do you notice the contradiction here? Remember, we assumed that a and b were reduced, right? So they shared no common factor, but notice a and b both share a factor of 2. And in fact, this will go on forever, because now I can say, okay, well, I replace b with this, and then it will turn out that d must be divisible by 2. This pattern goes on forever, and this is the contradiction, right? We assumed that the square root of 2 could be written as a fraction that was in reduced form. And we then showed that we contradict the assumption we make. And so the only conclusion we can come to is that whatever the square root of 2 is, it cannot be written as a fraction of 2 integers. And so this is the proof of irrationality, not only of the square root of 2, but of any integer which is not a perfect square. So something like square root of 3, square root of 5, square root of 7, all of those will also be irrational numbers.